Okay, I should be live now, I guess. Yes, yes. Okay, cool. So yeah, I am live. So yeah, so what are we doing today? I don't have any plan, so I thought I've been okay. Actually, I've been thinking about solving the crypto zombies thing and to learn Solidity in the way. And many people have suggested. I mean, it's been floating around. Crypto zombies is like the thing to learn Solidity in a fun way. So today was some fun time. So I thought, why not? Yeah. So let's do it. Chapter 1, lesson overview. Like, okay, cool. So in lesson 1, you are going to build a zombie factory to build an army of zombies. Our factory will maintain a database of all the zombies in our army. Our factory will have a function for creating new zombies. So it has a database. A factory will have a database for all the zombies in our army. Factory will have a function of creating new zombies. Each zombie will have a random and unique appearance. All right. Functionality giving zombies ability to attack humans or other zombies, but before we get there, we have to add the basic functionality of creating new zombies. Okay. How zombie DNA works? The zombie's appearance will be based on its zombie DNA. Zombie DNA is simple. It's a 16-digit integer like this. Okay, so this is a zombie's DNA. Looks cool. Yeah, that is exactly how a zombie's DNA would look like. Just like real DNA, different parts of this number will map to different traits. The first two digits map to zombie's head type, second two digits map to zombie's eyes. Okay, so what are these? So ooh. Okay, so head changes with the when I change the head gene. Okay. Note for this tutorial, we have kept the things in similar, and so zombies can only have 7 different type of heads, even though 2 digits allow 100. Yeah, that's what I thought. Like, yeah, okay. For example, the first digits of our example DNA above our 83. To map that to zombies head type, we do 83 mod 7 plus 1. So this zombie would have the 7th zombie head type. Okay, so I guess there are like how many heads then? There are 10 or how much? Okay, there are 7 head types, and okay, so yeah, 7 types of head. 18, right? So 8. Okay, so like from the DNA, this means that these 2 digit mean like map to a zombies thing. That is like these 2 digits should be head, but they would make a lot of combinations, so we are just using 7. Yeah, but I don't think that's important. In this panel to the right, go ahead and move the head gene, slide to 7th, the Santa hat, to see what trait the 83 would correspond to. Okay, to map that to zombies head type, we do 83 mod 7 plus 1 square 7. Okay, so 83 from here, and you use this to 7th. Cool. So like that, we just can have different zombies. Okay, cool, fine. Can we give like a name to? Okay, yes, we can give a name to the stream, and I have, I guess, the old name here. I think that's a bummer. How to fix that? How do I fix that? How do I change the name of the stream manager? Yeah, I must be like really dumb, which is correct in many ways. So how do you do that? Settings, That's chat. um how to change Twitch stream title. Transfer it is stream info, quick tabs. Okay, stream manager, create dashboard, settings. So this, oh yes, got it. Learning Solidity, with crypto zombies. Fine, cool. Yeah, category programming, maybe programming. Okay, yeah, now we're good. Very good. Okay, cool. So yeah, so that's the first chapter, I guess. Yeah, put it to the test, play with sliders on the resumes. Cool. We have played indeed. Clothes. Alright, chapter 2, contracts. Solidity's code is encapsulated in contracts. A contract is a fundamental building block of Ethereum applications. All variables and functions belong to a contract. So a contract is like a class or something, and this will be the starting point of all your projects. An empty contract named hello world. Yeah, until now it seems like a class. I think it's a class. Contract is a class. Okay, an empty contract named hello world would look like this. Version pragma, all the Solidity source code. So start with a version pragma, a declaration of the version of the Solidity compiler. This this code should use this is to prevent issues with future compiler versions, potentially introducing changes that would break your code. For the scope of tutorial, we will be able to compile our smart contracts with any compiler version in range of 0.5016. It looks like Prima Solidity. Putting it together, here's a bare bones starting contract, the first thing you will write every time you start a new project. Okay, all right. So there it goes. 0. Why don't I just, yeah, okay. Pragma Solidity. So this is where the version goes. Every time this has to be written when you write a contract, and then make a contract hello world. Beautiful. Yep. Okay, zombie just went. Yeah, that's working. You have triumphed Solidity covers, or what is this? Covers, whatever. In front of your might. Okay, lesson is unlocked. That's all that matters. Okay. Chapter 3, state variables and integers. Okay. So great job. Now that we have got a shell for our contract, let's learn about Solidity deals with variables. State variables are permanently stored in state variables are permanently stored in contract storage. This means that they are written to the Ethereum blockchain. Okay, think of them like writing to a database. Okay, all right. This will be stored permanently in the blockchain. Okay, got it. In this example contract, we created a event called unsigned integer and set it equal to 100. Okay, unsigned integer is unsigned integer, meaning its value must be non-negative. There's also an integer type for signed integers. Yes, there is. In Solidity, event is actually an alias for UID 256 or 256 bit unsigned integer. You can declare events with less bit 1632. Generally, you want to simply use event except its specific cases, which we'll talk about in little lessons. Our zombie DNA is going to be determined by a 16-digit number, right? The first one. Declare event. Okay, so we'll declare a variable, basically event that is DNA digits and set it equal to 16. Check answers. So basically this will be stored in the blockchain. Cool. Next, chapter 4, math operation. Math is Solidity is pretty straightforward. The following operations are the same as in most programming languages. Yep. Exponential operator. Okay. Yeah, that is power, and this is like exponent. Okay, so you can also do this, or you can also do that. Okay, cool. Put it to test. Create a event named DNA modulus and set it equal to 10 to the power of DNA digits. Okay, so event DNA modulus and set it 10 to the power. What is this sign is actually called? This I'm just going to use this 10 to the power of DNA digits. Okay, DNA digits, there we go. Check answer. Boom, nice. Next, structs. Okay, this is a class. Sometimes you need a more complex data type, so you make your own. That is struct, like in C++, or C. Struct person. Data types that have multiple properties. Now that we just introduced new type string. String are used for arbitrary length UTF-8 data. All right, cool. So you need me to create a struct named zombies. A zombie struct will have two properties. All right, so will it be made inside the contract? Yes, obviously inside the contract. Struct, everything is inside the contract, I guess. So struct person, actually zombie, struct zombie, and we'll have two properties. One is a string name and a DNA, event DNA. Cool. Check answer. Struct. What happened? Maybe try again. Okay, what's the problem here? Struct zombie. Our zombie struct will have two properties. Okay. Try again. What's the problem? What's the problem? no one is watching, so no one can tell me to. Okay, so what is the problem here? String, struct, zombie. What do we do it here or? Why do they highlight? Struct named zombie. Our zombie will struct will have two properties. Maybe hints. What is the problem? What is what? That was the problem. This needs to be up there. Why? Why does this need to be up here? So if I do uint DNA and string name, this will, and I'll just take it and put it in here, struct zombie, check answer. This will not work, but if I just take this, put it here, try again, put a space here, can't figure out why is why is there no error message here? String name. Okay, what is wrong with it? This is new. What is wrong with it? Remove start here, then change the order. What is this? Like, you change the order and it works? Crazy. Okay. When you want a collection of something, you can use an array. There are two types of arrays in Solidity: fixed arrays and dynamic arrays. Okay, array with a fixed length, 2 elements. Another fixed array that can contain 5 strings. Okay. String 5 fixed array, string array. I think it should be white, all white. It's like, why is it yellow? Okay. um, it's a variable. I guess this thing is just understanding it as a keyword and is making it yellow. But yeah, so you can also create an array of structs using the previous chapters person struct. Okay, so that will be the data type will be person, and that will be an array contain just the person properties, right? So dynamic array, we can keep adding to it. Okay. Remember that state variables are stored permanently in the blockchain, so creating a dynamic array of struct like this can be useful for storing structured data in your contract, kind of like a database. Acha. Okay, it's like a schema, right? So a struct is like a schema, and when you make an array, there can be multiple documents of that. Okay, so what's the thing here? You can declare an array as public, and Solidity will automatically generate a getter method for it. Other contracts would then be able to read from but not write to this array. So this is useful pattern for storing public data in your contract. Okay, all right. Okay, put it to the test. We're going to create a public array of zombie structs. Okay, so data type zombie, this will be a array, and we'll name something. Name it zombies. Very much normal. Okay. So you want to be public, so public. Okay, right. Function declaration. A function declaration in Solidity looks like this. Okay. Takes two parameters. For now, the body of the function is empty. Note that we are specifying the function visibility as public. We are also writing instructions about where the name variable should be stored in the memory. This is required for all reference types such as array, structs, mapping, and strings. What is the reference type, you ask? Well, there are two ways in which you can pass an argument to Solidity function: by value, by reference. Which means that Solidity compiler creates a new copy of the parent and passes it to your function. This allows your function to modify the value without worrying that the value of the initial parameter is changed, which is what we do normally. But by reference, you pass the memory, right? Which means your function is called with a function reference to the original variable. Thus, when you make changes to that, the real value also changes. Thus, if your function changes the value of the variable it receives, the value of the original value is changed, right? Normal. Now it's convention but not required to start function parameter variable. So for name variable should be stored in the memory. It's required for all reference types such as. So do you mean like name is being passed as reference variable and this as a value? Because this is definitely being passed as a value, but when you add memory, it's like adding and in C++. Is it like that? I guess. So you would call this function to be put it to test. Create a public function named okay, so function. So till now it's a mixture of Java and JavaScript. So people have who don't know much about, didn't get into learning more like most of JavaScript, or Java, they have like this confusion. Oh, is Java also called JavaScript or vice versa? So well, there you have it. Solidity's answer. It is also Java plus JavaScript. So at last, both of these are together. Function. Eat hamburgers. Create zombie. Okay, you know what? I'll just share this thing too. Let me just share this link of this stream. And how do I get that? Well, how do I get that? Edit stream, clip, manage goals, share. How do I do that? How do I get the link of this stream? Maybe if I go to twitch.tv and if I just go to, okay, that's bad. Streaming, it says channel, and how can you share this stream? Yes, got it. I'm just sharing it to Twitter. Learning live streaming myself learnings. Let me just be a Solidity. Okay. Tweet. Okay. Back to what we are. I just deleted the dashboard, Twitch dashboard. Shoot. Stream manager. Okay, cool. So I must be okay, cool. What we're doing, we're creating a function, by the way. So should I zoom it a bit? So control, where's my, okay, cool. So create zombies. So we're creating a function, and what to do, it should take two parameters, a name and a DNA. Don't forget to pass the first argument by value by using the memory keyword. Okay, so string memory whose, and it's called name, and another is uint, it's called, it's not memory. Okay, so when you pass argument using memory, it's called, you're basically passing by value, not by reference. So what is this? Is we're also providing instructions about where the name variable should be stored in the memory. Acha. Okay. Okay, so right, yes, because you're passing a variable like by value, you're providing a memory space for it, so that's why we use memory. But when we are passing through reference, it's just directly takes the original variables memory, so we don't need to allocate our memory. I guess that's the reason. So uint and DNA, kind of make it public, I guess, or it should be, and DNA, don't forget to pass the first argument value. Yeah, create a public function. So public here. Okay, so anything you want to make public, you should add a public. Okay, check answer. Cool. Next. working with structs and arrays, creating new structs. Remember our person struct in the previous example? Yes, I do remember that vividly. Now we are going to learn how to create new persons and add them to our people array. Okay. Create a new person. Okay. String name uint, and so you pass in the, okay, so people dot push. Okay, so you made this object and then you pushed it to the array of persons. Okay, so we can also combine these together and do them in one line of code. Right. Now note that array dot push adds something to the end of the array, so the elements are in the order we added them. See the following example. Push 5, 10, 15. Yes. Okay, cool. So fill in the function body to create a new zombie. All right. So fill in the functions. The name and DNA for the new zombie should come from the function arguments. So create a new zombie. So to create a new zombie, we will give the variable and let's call it zombie, and we'll just create a zombie now. So zombie will pass in the name and the DNA. Yeah, so we just made a zombie and we will push it to zombies dot push zombie. Fine, check answer. What's wrong? This should work. Okay, you want to do it in one line of code. Fine, we will do that. So boom, there we go. So be cool. Private and public functions. Solidity functions are public by default. This means anyone or other contract can call your contracts function and execute its code. Obviously this isn't always desirable and can make your contract vulnerable to attacks. Private default, so we just add this private guy here. Okay, add two numbers, and as you can see we use the keyword private after the function name, and as with function parameters it's convention to start a private function name with underscore. Okay, so when you are using private function it's conventional to just use underscore, put it to the test, modify create zombies and make it a private function. Okay, first of all underscore and just change it to private. That should work. Check answer. Fine, next. More on functions. In this chapter we are going to learn about function return values and function modifiers. Okay, function say hello, public, it's a public function, returns string with memory allocated, I guess. So in Solidity the function declaration contains the type of return value. Type driver. So whatever it will return, the function declaration will contain that. That is something really new. I haven't seen this any programming language. I mean, like this syntax, it's always here or something. Function modifiers. The function does not actually change state and solidity. That is, it does not change any values or write anything. So in this case we could declare it as a view function, only using the data, not modifying it. So the above function does not actually change state and solidity. It does not change any values or write anything. So in this case we could declare it as a view function, meaning it's only viewing the data. Okay, got it. Solidity also contains pure functions, which means you are not even accessing any data in the app. Consider this the following: event ub, it's private, pure, returns a event a into b. Okay, this function does not even read from the state of the app. It returns value. Return value depends on only on its function and parameters. So in this case we would declare a function as pure. Okay. So this is not pure because it's using this state of the contract, but this is pure because it's just using the value in its parameters. So that's why it's pure. It does not depend on anyone. So that makes it unpure actually. If it depends on anyone, else it's pure. Say view and view. Okay, it's only viewing the data, not modifying it. Okay, so is this also a view function? Because this also does not modify any data, right? It may be hard to remember when to mark function as pure/view. Luckily the Solidity compiler is good about issuing warnings to let you know when you should use one of these modifiers. Okay, so we are going to want a helper function that generates a random DNA from a string. Create a private function called generate random DNA. Okay, so function generate random DNA. It will take one parameter named string and returns in bracket, or yep, it returns a uint. I'm using uint. Don't forget to location of parameter to memory. Return string memory. This guy will view name but is not able to modify it, so we'll use a view here. The function body should be empty at this point. We'll fill in later. Okay, steer. So is it public or private? Private function. So it's a private function which is a view function and returns a uint. Yeah, cool. Chapter 11. Okay, we want our generate random DNA function to return a semi-random event. How can we accomplish this? Ethereum has the hash function keysack, whatever it is, key ECCAK 256. It seems like an encryption algorithm or something, which is version of SHA 3. A hash function basically maps an input into a random 256 bit hexadecimal number. A slight change in the input will cause a large change in the hash. It's useful for many purposes in Ethereum, but for right now we're just going to use it for pseudo random number generation. And also important, keysack, not keysack, whatever this is, 256, we'll call it K256, expects a single parameter of type bytes. This means that we have to pack any parameters before calling okay, K256. all right, so example, encode packed, so this only accepts bytes. Okay, so you have to convert that string into bytes, or I guess they call it pack here, pack that string into bytes. As you can see, the return values are totally different from this byte. Only a one character change is the input. Yep. Secure random number generation in blockchain is a very difficult problem. Our method here is insecure, but since security isn't top priority for a zombie DNA, it will be good enough for our purposes. Sometimes you need to convert between data types. Take the following example: uint 8-bit, a is equal 56, uint b is this, throws an error because a into b returns uint, not uint 8. We have to typecast. Okay, it's just normal stuff. In the above, a into b returns uint, but we are trying to store it as a uint 8, so we typecast the uint1 uint variable to uint 8. Alright, put it to the test. The first line of code should take K256 hash of. Okay, so do we need to okay, just keysack 256 and ABI dot encode packed. That's how you convert this string and typecast it as a uint and finally store it the result. Okay, so maybe just uint just grant and uint. That should do it. We want our DNA to be only 16 digits long. Remember our DNA modulus. Yep, so the second line of code should return the above value modulus. Okay, let's just see here. Alright, cool. Okay, putting it together, we are close to being done with our random zombie generator. Let's create a public function that ties everything together. We're going to create a public function that takes us in an input the zombie's name and uses the name to create a zombie with random DNA. Okay, so create a public function, takes an input, create a public function named create random zombie. It will take one parameter named, so it will take a name. Sure. It takes a value, that means that's all. It will be public, I guess. Public, declare public, and then it return function should run. It returns, right? Okay, public, and then the first line of the function should run the generate random data with a function. Okay, and it should return, so we'll store it. uint rand DNA, stored it. The solution should be, the second line should run around the create zombies function. Create zombie function which takes name and rand. So we're generating a random DNA here, that 16-digit guy. So we are now, and then we just have a name, and then we are again passing that name and this generated DNA into the create zombie function, which will just push this zombie with which has a name and a DNA to that array, right? So that's the goal here. So that's that. There should be 4 lines of code. Yes, it is 4 lines of code. Check the answer. Cool. Nice. Yeah. Just a second. I will just do one more thing right here. So okay, back to work. After the events, our contract is almost finished. Now let's add an event. Events are a way for your contract to communicate that something happened on the blockchain to your app frontend, which can be listening. Okay, it's like a what do you call, like it emits like in socket.io, right? Which can, or a webhook, which can be listening for certain events and take action when that happens. Okay, cool. So event, declared the event integers added, event x, its result function add event x unit y, public returns event. It adds the variables. After adding the variables, when it has the result, it emits this integer added thing, emits this integer added event. Okay, okay, cool. That was my family. Returning back to here. Okay, cool. So we are, what are we doing? Okay, events. Okay, events. Your app front end could listen to this. The listen for the event. A JavaScript implementation would look something like this. Your contract dot integers added, function error result to something with the result. A JavaScript implementation will look something like this. Your app front end. Okay, so what is this your contract? So when we actually okay, right, got it. So JavaScript has access to, I guess, some contract and its events. So when this event happens, you can either expect an error or a result that we are passing through here. Right, put it to the test. We want to event to the front end users know every time a new zombie was created, so the app can display it. Declare an event called new zombies. Okay, let's declare an event here. So we call it new zombie has been created event. Zombie, it should pass zombie ID, UINT, zombie ID, it should pass zombie ID, UNT, a string called name and a string called DNA. Okay, so there we have it. Our event has been covered and it will fire this event here as we push the zombie. Zombie ID, name, DNA, fire this zombie event here, passing the so what are we actually doing here? Create zombies, zombie ID and UNTNA. Okay, so this is the DNA. And what is the zombie's ID then? ID, what do you mean by ID? Like index or what? Zombies. Okay, so zombie ID is the index. Okay, cool. So what you can do is so are you doing ID array that push returns so you're telling when you push you get the length of the array. Now when you get the length of the array, the ID would be -1 according to the index of the array. So yeah, I guess this is it. So string got a bit distracted there. Okay, so what are we doing here? It should pass zombie ID, uint, name, and DNA. Okay, cool. So what are we doing here? What's the okay? Sorry. What am I? It's a function or something? Okay. It does not want this space here. Okay. Now it's fixed. Oh, now coming back to the next problem. Store the result of zombies.push -1 is a uint called ID. Okay, so I have to pass ID here. This will return the length, then we have to go -1 and pass in the ID. That should do it. Nope, that does not. Maybe you know what, maybe you should just not just, what if I just zombie.push why is there a I'm going to need a what, why is it showing a semicolon error here? Picks out the zombies we just ended. So. What am I doing wrong? What am I doing wrong? Right. Okay, that was not the problem. What is the problem with this guy? hints. The hint does not work. Why does the hint does not work? Yeah, I'll do it again. Event. New zombie has been created. Zombie with it should pass the zombie ID. Int zombie ID string name and uint DNA. Beautiful. And focus. Fire it. Show me the answer. Yeah. Oh, see, it is taking into account this space. I mean, how will I guess that? Like, I have to add a space here. Okay. You know what I think? It will not even work right now because I am actually not using a space in between these guys. So if I try again, it will not work. Great. Nice. Now it will work. Not even now. Okay, what's the problem now? Okay. Oh, okay. Cool. Nice. Okay. Okay, so there are events which can be emitted when you finish something. So that's it. That's that about events. Okay. Web3.js. Ooh, exciting stuff. JavaScript comes in. Our Solidity contract is complete. Now we need to write a JavaScript frontend that interacts with the contract. Ethereum has a JavaScript library called web3.js. In later lesson we will go over in depth how to deploy a contract and set up web3.js. But for now, let's just look at some example code for how web3.js would interact with our deployed code. So the web. Okay. ABI generated by the compiler. Zombie factory contract web3.eth.contract ABI. If this does not make sense, but we'll try to make some sense. Okay. Alright, so here we would access our contract. Okay, so first of all you have to access the contract you wrote in .sol file. So you are doing that here. web3.eth.contract ABI contract address, our contract address on Ethereum after deploying. So the contract has to be deployed. Zombie factory is equal to zombie factory contract dot add. That's how you connect your contract. It has access to our contract's public functions and events. Okay, so zombie factory is the variable. from where you'll get access to everything of the contract, because you just connected from the address you deployed here. So take the zombie DNA and update. So this is some sort of event. So this is a event listener. Taking some ID, some HTML ID, dot click, just fire this function. If our name is equal to dot val, call our contracts create random zombie function, create random zombie with a name. Okay, so listen for the new zombie event. Var event is equal to zombie factory dot new zombie, which is the event we wrote, and when this event emits we will catch it here. If error, return, else just generate zombie. And where is this coming from? Generate zombie, where is this coming from? Okay, this is a function. ID name, take the zombie DNA. Okay, so this is the function we have, and result dot zombie ID. So these were the variables. If you remember, we were just emitting with the event basically. So right, makes sense. Function generate zombie ID name DNA. Let DNA str is equal to DNA, converting that to string, pad DNA with leading zeros if it's less than 16 characters. Okay, nice. Let zombie details. First two digits make up the head. We have 7 possible heads, so to get a number of 0 to 6, then add 1 to make it 1 to 7. Then we have to have 7 image files. Okay, load based on this number. Nice, got it. Okay, so basically you're just making a object to be just load this image. Okay, 0 to 2, accessing the first substring, modding it by 7 so that you just have what, like the 0 to 7 value, basically a value, and then you're just adding 1 to it basically. So basically imagine you have 10 here, right? So 10 mod 7 would be how much? 7 3, I guess. Yes. And 4, so 4 is the head's fourth choice. Okay. Okay, so you just make this object to be sent to your server or whatever, right? And you got all this from just an event that emitted on the smart contract. And how do you, okay, you access this function and you, okay, it makes sense kind of, and you return the zombie details. So you made the zombie and you return the detail. Okay, let's see what kind of zombie you get. Okay, so where is the box? Where is the box? I'll write here the name. So what's actually happening here is that when I'm typing this guy, this value is, this thing is being triggered, I guess. This thing is, the value of this guy is going, and we are giving it to the create random zombie function, and then our event is basically generated, and we get these things using which we from which we just need the DNA basically. So we make the zombie details and we return, and we get all this stuff happening. So I guess this is the last chapter. Oh, it's done. Okay, congratulations, you have completed lesson 1 of Crypto Zombies. You're officially one step closer to your own games on Ethereum. Okay, so that's how you make a game. Like there's a lot of events being emitted, I guess. Show off your first zombie to your friends. Hmm, nice. Oh god, what the heck? Your friend built a. Mm-hmm. So it's just friend. Let's just share this on Twitter. It'll be fun. Hey, do you have the? No, I don't have this. I need the tweet. Where is it? The link of the stream. Hmm. Okay. BTW. Streaming here. Pew, dot dot dot. Uh, oh, what the heck did I do? Shit. What? Oh, sorry. What the heck? Delete again. What the heck? I just did not. I just forgot to add the link. BTW. The source code of this isn't this Loom network. Crypto zombies. Lesson code. Okay, cool. All right. Okay. Next, I guess. Actually, I have to go now. I guess that's it for today. Let's. Actually, not today. Now I'll come back, but I'll just have to stop the stream. So, yeah. Okay, I am actually watching me now, so it's been just one viewer, and one time it just went two, which was really great. So I'll just say bye to me and close the stream off, and yeah, I'll probably stream the lesson 2. Yeah, I will definitely do that. Probably, like, I have lots of things to do in the world. Okay, cool. Bye everyone. Everyone, really. Okay, it's just me. um, uh, Stop. How to stop the stream from the OBS? Right, stop.